All right, in this example, we're taking carbon monoxide, reacting it with hydrogen to produce methanol. We're asked to predict the moles of methanol formed when we place 5 moles of carbon monoxide and 8 moles of hydrogen together in the same container. What makes this problem difficult is that we don't have that particle diagram to go off of. I can't draw these and circle the sets every single time. We're going to have to be able to do this without a picture on our paper. So our first step is to rewrite the balance equation. We're going to construct a full BCA table, that before, change, and after table, making sure that we write down the correct balance equation because this is stoichiometry and it involves using the coefficients from the balance equations as our mole ratio. So our B represents the quantity that we have before the reaction starts. So we place 5 moles of carbon monoxide into the container and 8 moles of hydrogen into the container, and there are 0 moles of product at the beginning. Next, the C, which represents your change. That is the quantity of reactant that is being used and the quantity of product that is being made. And we know that the limiting reactant is always the one reactant that is completely used. We subtract all of its starting quantity. It's going to end as 0 at the very end of this reaction. But I don't have that picture to go off of. I don't know which one the limiting reactant is. When you don't know which one the limiting reactant is, I want you to pick the first reactant and test to see if it is the limiting reactant. So we're going to test to see if carbon monoxide is the limiting reactant. So I'm writing a little LR here. If carbon monoxide was limiting, we know all of it would be used. So if you start with 5 moles, all 5 moles would have to be subtracted. And we know that limiting reactant quantities get carried over to all the other columns. I'm going to put a 5 underneath of hydrogen and the 5 underneath of your product. And we know that reactants are used, so reactants always get minus signs, and products are made and they always get plus signs. Then we insert that fraction into the other columns, everything but the limiting column. And that fraction is the key to stoichiometry. This is called your mole ratio. We look at the coefficient of where you are, and you're going to divide by the coefficient of your limiting reactant. So if I'm solving for the mole ratio of hydrogen, its coefficient is 2, so I'm going to place a 2 in the numerator. And the coefficient of our limiting reactant right now is carbon monoxide, and its coefficient is 1. So it's 2 over 1, and I'm going to solve this. 5 times 2 is 10, and that negative sign just gets carried down. And what this is saying is, in order to react all the carbon monoxide, we would need 10 moles of hydrogen. But pause. Look at what you have before the reaction. We only have 8 moles of hydrogen at the beginning of the reaction. But yet, it requires 10 moles of hydrogen. So in this case, we don't have not enough hydrogen here. This is not possible to do. We can't use 10 moles of hydrogen when there's only 8 moles to begin with. So right away, I see this is a problem. I can't continue on with my BCA table in this manner, meaning I can't continue using that carbon monoxide as a limiting reactant. This is no go. So we're going to cross out what we have here, and we're going to create a new change row. So since we now know that carbon monoxide cannot be the limiting reactant because we don't have enough hydrogen, we pretend that we didn't do this work. We're not going to look at it again. Now we're going to make the hydrogen the limiting reactant. So we have a new change row. Now hydrogen is going to be assigned the LR. And if it's the LR, we're going to subtract all of its starting quantity. So minus 8 for the hydrogen. So if hydrogen is limiting, we're going to copy its value to all the other columns. That 8 gets copied over, reactants get minus signs, products get plus signs, and now for that mole ratio fraction. The coefficient of carbon monoxide is 1. The coefficient of the limiting reactant, hydrogen, is 2. And so 8 divided by 2, that gives me 4. And you pause. Yes, you have enough carbon monoxide. You have 5. You only need 4. So this is correct so far. We're going to do the same thing for the methanol. Its coefficient is 1. And the limiting reactant, its coefficient is 2. And that is also going to give me 4. So we do have the correct change row now. Now I can complete the after row. After is the before together with the change. So for carbon monoxide, it is 5 minus 4. And we get 1 mole of carbon monoxide. Hydrogen, 8 minus 8, that gives us our 0 because it's our limiting. And the methanol is 0 plus 4, and that gives us 4 moles of methanol. So our limiting reactant was hydrogen. I'm going to put a box, highlight that limiting column just to emphasize that hydrogen is our limiting reactant in this problem. I know that it is limiting because it is the reactant that is 0 after the reaction. So I go to the after row, whichever one is 0, that's your limiting reactant. Your limiting always has to be on the left side of that arrow. And one more thing about that limiting reactant. Its coefficient 2. We use the coefficient of 2, okay, for hydrogen because it's limiting in the denominator of all the fractions, your mole ratios. So I want you to pick up your colored pencil, circle the coefficient of your limiting reactant hydrogen, and then circle the denominator of all your fractions. Just so for right now, as you're starting to practice this, you know that the coefficient of your limiting is the denominator in all the fractions. And one more thing about that limiting, its value was 8. Okay, its starting value is 8. And so we subtracted all of it to get that 0. And it's the 8 that was transferred over to all the other columns. Okay, your limiting determines everything. Your excess reactant is the reactant that you have extra moles of, and that's going to be your carbon monoxide. And then finally your product, you have made 4 moles of CH3OH. So to answer these last questions, okay, you can look at your BCA table. We already said hydrogen was limiting, your excess is CO, carbon monoxide, and according to your BCA table, you have 1 mole of carbon monoxide left over.